Hi, I'm Kelsey Hightower, Principal Engineer at Google Cloud. In this video, I'm going to be talking about when and why you might think about migrating to Google Cloud and what that might entail. That could mean you're ready to expand your offering or drive profitability to increase the valuation of your company. As things start to get a little more complex, I want to share how we think about it at Google Cloud. All right, so one question I get all the time is, I'm already on AWS, why would I consider moving to GCP? This is a good question. AWS has lots of nice services, but there are some scenarios where it actually makes sense. Number one, typically you're going to be expanding your business to customers that prefer to have their data and their compute on GCP. Second, if you're all in on Kubernetes, and there's lots of companies who've chosen to run all of their services, including things like databases inside of Kubernetes. In that particular case, I think GKE definitely stands out from the crowd in terms of a fully managed, full-featured Kubernetes offering. And those tend to make a ton of sense. The other areas that make a lot of sense are around things like data analytics. While you may have a great compute platform set up over on AWS, there's a lot of customers who still found something like BigQuery to be a much better solution for analyzing all of their data. So you may have some situations where you just choose to use the best of breed across each of those cloud providers. The other front is going to be on the serverless side. While people like things like functions and other offerings on AWS, one thing that I think a lot of people are starting to move towards is this container-based serverless offering, and that's where Cloud Run comes in. Right, multi-cloud is important because, look, not every customer in the world runs on a single cloud provider. You'll have some customers split across all the major cloud providers. Let's say you're in the business of servicing all the customers globally, right? You don't want to limit your total addressable market to a single cloud provider. In that case, you will have customers that will prefer that their compute and their data be close to their own compute and data stacks running. So whatever cloud provider you pick, you will soon probably find yourself in a scenario where you will have to support your managed service on the other cloud provider. In many cases, you'll also be servicing data that originates from a different cloud provider. So in many ways, it will make sense to have the ability to do that computation close to the data. Data gravity is real, and one way to solve that problem and to reduce your latency and high networking fees is to move the compute to where the data actually lives. This all makes the case for using and leveraging multi-cloud. Now the key is doing it correctly. All right, let's talk about different approaches on how doing it correctly. So number one, you want to make sure you can re-leverage as many of your workflows and getting things done as you can. So this is why open source becomes super important. If you're going to pick a database, I would suggest something like the Postgres protocol, where you can use a managed Postgres database on any of the cloud providers you want to choose. Second, in compute side, you think about deployments and automation. Again, this is where I think Kubernetes saves a ton of time. Really what you're after here is that if you pick a set of technologies, you want to make sure that they work across the various boundaries that the cloud provider set up. If you invest in getting it right on one cloud provider, your goal is to be able to reuse as much of that investment on the other side. So this is where I think compute stacks like Kubernetes lend a huge advantage to customers that really are serious about doing multi-cloud, but doing it in a way that's efficient and doesn't require reinventing the wheel every time you want to avoid or onboard a new cloud provider. The other thing that comes up a lot is risk management. Maybe your board is interested in what happens if your particular cloud provider were to go down, or in some cases start competing with your business. How do you mitigate that risk? The last thing you want to do is be funding your competition. So let's think about risk mitigation. One thing that can help you going forward is the ability to actually run your stack in another environment. So this is another case for a multi-cloud. And again, things like backups. If all your data is stored in one particular, let's say S3, where you store all of your blob data, sometimes it makes a ton of sense to be able to back that data up into a different cloud provider. This helps prevent anything like a misconfiguration, or you might lose your encryption keys and lose access to that particular data. Backups have always been a good idea, and I think that doubly so in the world of multi-cloud. All right, so one of the best use cases for going multi-cloud that I've ever seen, actually the cases that actually turn out to work really well, are the cases where people that are all in on Kubernetes. So one of the goals of Kubernetes has always been to provide this cloud provider agnostic API, not just for running applications, but configuring them, deploying them, and integrating things like security policies, networking, the whole nine. Think of Kubernetes as this multi-cloud operating system. So typically, once you have Kubernetes as your layer of abstraction, you can hide all of the differences, at least on the compute side, of most of the major cloud providers. So your goal here is to, look, you have choices. You can use something like a managed Kubernetes offering. So if you're on AWS, that would mean something like EKS. If you're on Azure, that would mean something like AKS. And if you're on GCP, that would mean something like GKE. All of those options will give you a common Kubernetes API. So once your team builds out its toolings and workflows against that Kubernetes API, the goal is you should be able to reuse all of those workflows across the various cloud providers. Right, so let's say you haven't chosen a cloud provider, or you have chosen multiple cloud providers, now you're looking to consolidate. Now, one thing that we've seen is when people really go all in on Kubernetes, meaning, look, they consolidate a lot of those VMs and now they have a new problem, managing Kubernetes itself. Now, the question you may have are, is Kubernetes all created equal across all cloud providers? Well, at the very top, the answer is true. Yes, you all end up with a Kubernetes API. But underneath that Kubernetes API is a cluster, worker nodes, security policies, the whole nine. And so this is where GKE tends to stand out. So there's two things to take note of. Number one, if you still have a valid need to use those other clusters, you can connect those clusters to GKE Connect, which will give you a single place to manage, view, troubleshoot, and debug all of those clusters. And you can also manage things like credentials centrally. If you really want to go all in, then you can think about GKE as being what I still consider the best of breed Kubernetes offering in the entire space. So what makes it great? What makes it stand out? Well, it's the end-to-end manageability of it, not just the control plane or the multi-region or multi-zone high availability. There are things that go into day two. For example, if you have clusters spread across multiple regions, let's say US East and US West, you can actually have Kubernetes and GKE manage one global load balancer that will send traffic across both of those clusters. And we just give you a single place to manage all of that. The second thing to think about here is what happens when you're not that interested in a Kubernetes cluster to begin with. And that's where things like GKE Autopilot really start to stand out. GKE Autopilot is all about making the cluster disappear and just giving you that standard Kubernetes API with all the strong security defaults, and then you can just focus on your workloads and not the cluster. Some of you will, before you get to multi-cloud discussion, you have to think about at least one cloud to start with. And so if you're going to choose that kind of home base for your multi-cloud journey, or your first cloud provider in this whole equation, you got to ask yourself a single question. Where do you want to spend most of your time? Do you want to spend your time managing a Kubernetes cluster, or do you want to spend your time using a Kubernetes cluster? I think there's a huge difference between those two things. And sometimes it just makes sense to make GKE your home base, and that doesn't preclude you from using the other cloud providers. It's just that you'll have an initial easy experience to get yourself started. So one of the things that's most important about data analytics is that something that GCP is really good with. You know, Google's heritage is machine learning, big data. We've been solving those problems for a very long time. One of the number one products most people like, of course, is BigQuery, right? So think about it in the way of putting all your data in one place and then just running standard SQL queries across it. So this is kind of a landmark feature that simplifies the whole big data thing, right? So out with the data pipelines, in with the simplification of centralizing your data, and then giving people simple access to it. The other thing is like fully managed services around the things that you probably are using already, whether it's Dataflow, or maybe you're into Apache Spark. There's a fully managed serverless offering of one of those. And the other big up-and-coming thing is running a lot of data scenarios on Kubernetes itself. So you have this whole range of data analytics tools coming from the place that helped coin those terms around big data and MapReduce. We just become home to all of those standard protocols and tools along the way to make that much simpler. If you're on a different cloud provider, let's say you're on AWS, you'll probably find that you have access to very similar tools. One tool in particular that I think stands out is the BigQuery approach. So the one thing that was amazing about BigQuery when it was introduced almost 10 years ago is this concept of decoupling the compute from storage. So a while ago when Google produced their own MapReduce paper that really kicked off the whole big data movement. When you think about tools like Hadoop and Spark, while those are cool, you can have a managed version of those, BigQuery literally changes the game. Instead of having data flow in and out of these complex pipelines, imagining being able to centralize your data in one place, and the BigQuery storage engine makes it so efficient that then you can actually just query terabytes or petabytes of data using a common interface. I think this is still one of the things that makes BigQuery stand out of all of it. So if you've tried many of your cloud providers' native solutions and you're probably not happy with the performance or scalability, I welcome you to give BigQuery a try. I think it's the #1 service people use regardless of their base cloud platform. And I think that's one big reason why people choose BigQuery regardless of where their home cloud is. Typically, when I see migrations that really work well, there has to be a reason to choose another cloud provider. No one's in the business of changing cloud providers just for the sake of it. So the #1 thing we see typically is that people will choose to use GCP machine learning or data analytics tools. So you can imagine having your compute in your cloud provider of choice, but you really want an advantage on the other tools like data and analytics. So this is where typically people will ship their data off to GCP so it can be analyzed and processed in a way that's scalable for the whole team or for the whole business. But you have a problem here. Since all of your compute is in one cloud provider, you will incur tons of data transfer costs and additional storage costs of that data moving between the cloud providers. That thing we talked about earlier, data gravity. So this is the concept that, look, if your data holds the most value for your organization, then the compute typically follows the data. So most of the successful GCP migrations that I've seen is when the data analytics tools really take off and offer business value, then the compute is soon to follow. And the companies that make the transition the best are typically the ones that are already adopting something like Kubernetes in their cloud provider of choice, and then they can actually take those configs. And the most surprising thing of it all, most people find that GKE offers a little bit more manageability than they were used to before. You click a single button and the whole cluster, control plane, and the worker nodes are fully managed. So a lot of people actually see that they end up spending less time administrating Kubernetes, and they can enjoy the same uplift and benefits that they did for data analytics and ML. All right, so another big migration question is, I'm all in on serverless. So maybe using something like AWS Lambda. Look, it's a really popular serverless platform. This is where you write functions as a service and you connect them with all kinds of events. But look, through experience, what I've noticed is that those functions tend to grow in complexity. Some of them are actually bigger than normal applications, typically because you still end up connecting to things like a database for handling security concerns. And so what happens when you have an application that outgrows the simplicity of a function as a service, or you have an existing application that you would like to run in a serverless way? So this is where Cloud Run, I think, changes the game completely. When Google decided to revamp our serverless offering, we've already had things like App Engine that's been around for a long time. So if you're interested in a platform as a service where everything is fully integrated, check out App Engine. It's still pretty good in that regard. If you're just looking for a function service, then we have Cloud Functions that's going to be closer to AWS Lambda. But that doesn't necessarily address the situation where you have existing applications that you would like to benefit from the serverless model. Like, who wants to manage infrastructure or clusters or deal with all of that complexity? So when you're considering, do I migrate, what is in it for me? Well, if you've outgrown the functions as a service platform, then Cloud Run is super interesting in this regard. Number one, it's backed by a standard interface called Cloud Native. So if you ever choose to maybe run outside of the cloud, or maybe you have to run on multiple cloud providers, you can layer on top of any standard Kubernetes offering, whether it's a managed service or one you spun up on your own, with the Knative interface. But why is Knative so important? Let's get back to that managed service Cloud Run. The idea here is that the same containers that you build on your laptop, so maybe you're packaging things in Docker, those containers that run great in a Kubernetes cluster can also run great in a serverless environment. So think about being able to run all your containers without the cluster overhead or management. Things scale down to zero, you can pay per use, but here's another interesting feature. Once you become very successful, or you start to have lots of customers, then you're gonna need to worry about performance. Look, there's all kind of tricks you can do on things like Lambda or even Cloud Functions if you want to, but why go through that complexity? If you know that you're getting a lot of traffic, you can turn off scaling to zero on Cloud Run. You can actually turn on always on CPU. So that means your application will run just like it did on a virtual machine or inside of a Kubernetes cluster. What you can then do is reuse your existing expertise without rewriting all of your applications. Just hand off that container to Cloud Run, and you're gonna have the same serverless controls that you're used to in an environment like Amazon's Lambda. So if you've outgrown the initial promise of serverless, but you would like to expand it to the rest of your application portfolio, there is no way that you gotta miss Cloud Run. So I think that's gonna up-level your ability to run and deploy applications, but not have to manage them all. Yeah, there's gonna be cases where people are on, let's say you're on AWS already, and maybe you're really doing well with virtual machines, and maybe you have a little bit of Kubernetes sprinkled in. You revisit your architecture and say, look, there has to be a way to simplify all of this. Now, you like the ideas of serverless, but maybe something like Amazon Lambda doesn't fit the bill. Look, number one, you've already invested in containers. You're using industry standard frameworks like Ruby on Rails or Node.js. And the last thing you want to do is refactor all of those applications just to flip the platform. So maybe you're looking for an application environment that's fully serverless that supports that existing investment. And so this is where Cloud Run comes in. So if you think about this, maybe you have a bunch of VMs and you're just using Docker to pull down a set of container images and have it run those. You can take those same container images and give them the Cloud Run, and you get those same serverless knobs that you see in AWS Lambda without all the trade-offs on what you can and can't run. So one good example of migrating to serverless or going from an existing environment is the ability to deal with the complex auto scaling. Look, we've all tried to do this. You have a bunch of VMs and your goal is to have those VMs spin up quick as possible, attach themselves to a load balancer, and hopefully not drop any of the traffic that your customers are trying to create on your platform. There's various ways of solving this. If you're in the VM world, you can use a collection of Terraform, auto-scaling groups, and load balancers. Well, if you're in the Kubernetes world, you can also do the very similar thing and let Kubernetes manage it for you, but you still have the problem of managing the cluster underneath. But what if you wanted to keep those same container images, the same Kubernetes style config, but eliminate the need to think about auto-scaling at the low levels of a machine? Again, this is where something like Cloud Run really stands out from those two approaches. You can actually take some of those things, including the apps that you already have today, and then your auto-scaling needs are just handled transparently by the Cloud Run platform. So if you don't want to spend too much, you can set a max instances to be something like 10. And if you want to make sure that you have high performance, you can even set the minimum number of instances that will always be at the ready, so you don't have to worry about things like cold starts and missing that critical traffic that your users are trying to create. All right, so we've already covered GKE being the best Kubernetes offering in the business, but you may not be yet convinced that containers is the right next step for you. So let's say that you're all in on virtual machines, like that was the original cloud compute offering. So maybe you've been on AWS for a while and you're all in on virtual machines, and you probably invested in a ton of tooling to manage those virtual machines. So why would you even move containers in the first place? Well, step one would be from a packaging standpoint. There's a lot going on in the industry and around understanding what's actually inside of your software. So we're starting to talk about software or secure software supply chain. The goal here is that we want to produce reproducible artifacts. We want to know what version of Ruby or Java or C++ is inside of that image. We want to know what libraries you depend on. And in order to do that in a very repeatable and efficient way, then the container image stands out here. So even if you're using virtual machines, it may be in your best interest to consider adopting container images to package your software. It's going to make upgrades of those VMs much easier. You can actually now decouple the lifecycle management of the virtual machine and the lifecycle management of the application. So you can simplify the VM by removing all the language things like Ruby, Python, and Java, keep those off of the Linux VM, and instead you move all of that where it belongs next to the developer's application. You can control all of those things in one spot and keep your machines bare metal. The smaller the things on your virtual machines, the smaller the attack surface. You want to simplify those and compartmentalize inside of a container image. So let's say that's your next step. Let's say you have VMs and you have to keep your same tooling, and now you're managing VMs with containers running on top. Well, you're going to find that I didn't necessarily reduce all of your complexity with that. You're still probably being pretty wasteful. One container per VM is not going to get you the same benefits of what we call bin packing. So that brings us to the next reason, why Kubernetes? Well, listen, if you think managing your applications in container images to give you all the repeatable things we talked about before, then you're going to start thinking about a better form of orchestration and another situation where you can actually save a bit of money. I've seen a lot of customers go from like 1,000 VMs with maybe 5 to 10% utilization down to maybe 250 VMs and getting closer to 30 and 40% utilization by being able to have something like Kubernetes pack all of those container images on a smaller subset of VMs, therefore saving you money in the process. Well, then your final choice comes down to, well, what Kubernetes offering should I run? And I talked about that a little bit earlier. When you compare all the Kubernetes offerings that are out there and you want to focus on things like less maintenance on your part, industry standard best practice, and deep integration with the rest of your cloud provider platform, again, that's where I think GKE stands out. So if you're going to move to containers, maybe your first step is adopting container images on top of those VMs. And if you're ready for the rest of the value that's able to be brought to the table, then you probably want to think about GKE no matter what your starting point is. All right, so you're listening to this and you're like, Kelsey, look, I'm sold. I'm going to go ahead and start moving things to GCP and more importantly, GKE, the Kubernetes offering. So let's say we start and have to be very pragmatic about this to make sure we get enough value and bang for our buck. We got to have a few goals in mind. So let's use the one around cost saving and management overhead. Number one, I just want you to think about all the steps that your team goes through, whether they're automated or not, goes into managing all of those virtual machines. I'll wait. All right. Now I'm pretty sure if you're like most companies, you're probably at tens or hundreds of steps. Automated steps also need to be maintained, and they're also fragile, and they can actually break down when you have to add new features or capabilities to your workflow for managing your platform. So even though it feels like it's free today, maintenance is an ongoing burden, even for fully automated setups. The second one is cost savings. So in the previous example that I just gave you, we're talking about saving your team's time. The goal is to give them their time back on low-level infrastructure so they can go focus on higher level and more important things for your business. The second one is actual cash in your pocket. Another exercise I want you to do is go look at your current cloud bill. You see that number? It's probably a little too high. So one thing you can do is look at where you're actually wasting money. Again, let's go back to that previous example. If you have 1,000 VMs all running just one application each, then my guess is you're probably at 5 to 10% CPU utilization, not to mention memory and storage, all that is being wasted. So the next thing I want you to think about is how to articulate and describe your application using those container images that you're already running. Once you have a container image, you now have the price of admission to describe how you want your application to run inside of Kubernetes. So here's the second step. Now that you have that container image running on VMs, the next thing you're going to do is start crafting out a very simple set of Kubernetes configs. This is what we call things like deployment objects, and we can describe things like load balancers. So I want you to click a GKE cluster and create it, and this will be your staging environment. So here's what you're going to do. You don't necessarily need to think about porting all of your existing tooling to GCP. That wouldn't be very efficient at all, and honestly, it won't be necessary. The thing you can think about here is, once you have Kubernetes, you have a much more sophisticated API that will automate the management of the low-level infrastructure. So your next step is going to just simply be to describe how your application runs today, but using Kubernetes configuration language. Most people call these YAML files. And once you articulate what you have, you can actually compare and contrast things running on your VM, and then you can tell Kubernetes to take your containers and pick the right VM underneath the scenes. If a VM is underutilized, Kubernetes will be smart enough to figure out how to pack multiple applications on a single set of VMs. So at this point, you now have your path. Start with those container images, have a couple of goals in mind. Number one, to save your team time on administration overhead. Number two, to save your company money on actual compute costs. And with those two goals, I think you'll have your path forward in adopting Kubernetes slowly but pragmatically. Yeah, so one of your fears would be, all this talk of migration sounds like a bunch of downtime without any value. The last thing you want to do is having your team hitting the pause button on future development for the next 6 months. But I want you to think about it a different way. Number one, it shouldn't take 6 months because there are a ton of expertise around Kubernetes at this point. There's books, there's blog posts, there's even official training courses on how to do this. Number two, we're not really changing everything. Kubernetes still runs on top of the same Linux VMs that you're probably using today. So what you're really getting is more of a streamlined workflow and consistent that incorporates a lot of things that should be on your infrastructure roadmap. Now you're probably listening to this like, Kelsey, we don't have an infrastructure roadmap. Now you're making my point. More than likely, your current infrastructure is probably a collection of homegrown scripts and automation, and you just kind of go with the flows as things break or need to expand. What if you could be way more strategic in that? What if you could learn from 15 years of people doing this around the world and giving us a much better starting point? That starting point is Kubernetes. So the way I want you to think about this is Kubernetes is going to save and ramp up your roadmap, give you all the features that you're probably trying to build on your own, like standard logging collection, metric collection, thinking about how to expand and auto scale things in a very consistent way. Onboarding new team members becomes much easier when you're using some industry standard tool like Kubernetes versus having to teach them all the custom ways that your company goes around it. And also, you can do this applications at a time. You don't need to go wholesale. You can actually start with VMs and move one or two applications over to Kubernetes, and they can actually live on the same network. Applications running in Kubernetes can talk to the VMs, and the VMs can actually talk to the applications running in Kubernetes. It doesn't have to be an end-all be-all transition. You can move slowly from one platform to the other. I'm going to let you in on a little secret. Sometimes it makes sense for a few apps to stay on virtual machines. Maybe they're big, heavy databases that benefit very little from Kubernetes. It's okay to mix and match. But what we've seen in the past is most customers get a lot of mileage out of moving their applications and open source projects into the Kubernetes landscape. All right, so you're thinking about all of this multi-cloud stuff. It's like, what's the point? What's the purpose of it? Well, when I was coming up in the technology era, there was no such thing as multi-cloud, or we never said things like multi-vendor. I'm going to give you an example. If you walk into a data center, you might see that your servers are made by one vendor, your storage appliances are made by another, your networking stack is totally made by a different vendor, and they're all connected through some standard interfaces. But never once in my career have I ever heard the phrase multi-vendor. Why? Because it all tends to work. And typically, the network connectivity is so close together that you don't even think about things like latency. So, in your own data centers, in your own environment, you tend to pick the best of breed. If one vendor is really great at compute, you choose their offering. If another vendor is good at storage, you choose theirs. You've never locked yourself into one vendor this whole time. Now, when we get to cloud, there's one fundamental difference. When we say multi-cloud, we're really not talking about each cloud provider being radically different than the other. We're talking about best of breed. Each of these cloud providers brings something to the table that's typically unique, along with the commodity stuff that you're used to. So why would you do it? Well, let's think about this. What if I took away things like the network complexity? What if there was no latency around the cloud providers? How would you make a decision? Would you really only choose from one menu of services and products? If there was no additional networking overhead and you could use BigQuery because you identified it as the best of breed, wouldn't you take that option? If you liked the database on one particular cloud provider, but you thought GKE was a much better Kubernetes experience to save your team time, wouldn't you take that option? Well, that's what people are doing these days. You can now bridge the network connectivity at the lower level through a third party or intermediary to reduce that network latency to allow you to really start to think about best of breed technologies across these cloud providers. As the saying goes, you can't necessarily be good at everything. So you as a customer, you should have a choice in which ones you pick. And ideally, you pick the best components to run your actual business. And so I would encourage you not to focus so much on multi-cloud and why you should just create the same application in two places. This is more about picking the best of breed of services across all cloud providers that offer them. All right, so today we talked about tons of configurations around multi-cloud, migration from one cloud to another, maybe in a scenario where all of your discounts have expired and you're looking to renegotiate, or maybe you like Kubernetes and you've gone all in and you're looking for a much better Kubernetes offering, or maybe you want a different approach to serverless that actually fits your existing applications and the roadmap that you've drawn for yourself. If any of those things are interesting to you, please reach out to us over here at Google Cloud.